Welcome to the Engerati studio. I'm Rose Bundock and I'm joined now by Oliver Schroedel, Senior Key Expert for Distribution Automation at Siemens.
Hello.
Oliver, thank you for joining me.
Thanks.
I think a lot of the content of this show will be focusing on the complexity of integrating distributed generation, renewables, which is kind of causing DSOs to really need that eyes on the grid. I know as Siemens, one of your big messages is about solutions for distribution automation and the mid to low voltage level. So perhaps you could tell us a little about the kind of drivers you're seeing that are making this, causing DSOs to invest in this technology.
Yeah, fine. Yes, we from Siemens, we have a lot of talks with customers about grid innovation, what are the next steps for the distribution automation grid at all. And we do it also on an international basis. So we're not only looking and focusing to Europe, we're looking all over the world as a kind of a global player. And it's quite interesting because the drivers mainly a little bit different, but at least it's about the grid automation at all, to keep, as you told me, an eye on the grid, to monitor new load scenarios, or even to integrate new renewable infeeds or infeeds at all. And all this kind of stuff we try at Siemens to find flexible solutions. And these solutions are mainly driven together with the customer. So we could look about the customer drivers, and one of the most important drivers in the distribution grid at all is the outage management topic. Because he has to provide energy, and if the energy is not there and not to be delivered, then he has a problem with statistics and all this kind of stuff. And that is the reason why we took a closer look on this kind of outage management, and not even on the medium voltage, also on the low voltage grid.
Okay, and what kind of benefits are customers seeing from adopting the technology?
Yeah, what is one of the quite biggest advantage is very, very clear, to reduce the outages or reduce the outage times. So every big utility are monitored by KPIs like SAIDI, SAIFI, so the outage duration or the outage frequency. And there are some international statistics where you can very, very good be ranked from an international perspective. And if you see, okay, for example, Singapore has a SAIDI index for less than 1 minute outage a year. And if you go to some other regions where you have 120, 140 minutes a year, then you see that there's a big gap between. And also these kind of stuff can be focused and can say, okay, on which kind of level my city, my energy supplier is. And then it comes to a quite clear, interesting point, okay, how we fix this.
You referenced a couple of European case studies. Perhaps you could just elaborate on those.
Yeah, for example, there's quite interesting studies from Chemo available, where they put these kind of international distributions on matrices. And then you see, okay, what will be the cost for the energy delivered through the medium voltage distribution and low voltage distribution grid against the, let me say, the outage times, so the SAIDI, so the outage duration. It's quite interesting to see, for example, that highly developed grids like we have here in Amsterdam, or even in Germany, in Frankfurt, for example, or in Asia, have also quite good grid performance, but also the fee is quite low, so it's on a reasonable price level. And if you go, for example, for these kind of, let me say, less automated grids where a lot of manual work has to be done, the prices are quite high because you have to pay the manual work. And that is quite interesting to see that there's a relation, and this kind of stuff can pay off.
Okay, and you mentioned a UK project.
Exactly. So for example, we do some, so we start with the monitoring first. And for example, at Scottish Power, we do currently a pilot project together with Scottish Power to have a very, very nice application. It's called Fault Passage in the Cloud. So we have a fault passage monitor installed on an overhead line at Scottish Power. And this kind of overhead line monitor is not going to SCADA, or it's going to a cloud application like we have here. And this kind of cloud application shows you even where the FPI is sitting, the fault passage indicator on the network, and also what is the status. So you can get with the crew very, very fine, very, very fast where is the fault located, and then you can bring the crew exactly to the point where the fault is. And you have also a small integrated tooling inside where you have the opportunity to say, okay, the crew is on the way, so how long we take for this fixing and so on. So that is the first topic, starting with monitoring. But the next step is automation. and remote control at all. So not only to bring out the crew to do some switching for isolation, no, to do it automatically or do it from remote control. So with secondary automation in secondary substations which are automated, where you have motor drives, where you have reclosers in the field, all this kind of stuff. And it's the second part where you can improve your statistics very, very high. And it's also not needed to automate the whole grid. Mm-hmm. So we have some studies made very, very interesting that only a percentage of 20% is very, very feasible to increase the benefit in your decided statistic about 80%. So that's quite fair. 20% investment, 80% improvement, that's quite fair. And the last topic in our grid automation portfolio are the applications, like these applications on cloud-based monitoring, but also some applications like closed-loop self-healing application, which automatically and autonomous detect where the fault is, isolates the grid, and automatically restores the grid in less than some seconds, mainly on the switching time, or even faster if you reclosers. So that is quite interesting, this kind of portfolio from, let me say, improve first of all with monitoring, do some normal automation, up to really, really closed loop and very fast self-healing. For example, here in Netherlands, nearby Stedin, we have our nice self-healing grid installed at Rotterdam, where we have these kind of closed loop automation placed on a decentralized way, in a semi-decentralized way. So we extended an existing substation with some application, where the application is there for the outage management. And we do not stress the SCADA system at all, but we stay in close cooperation with the SCADA system, so they can switch on, off, and the SCADA engineer can do their normal work, the daily work business, but if there's an outage, it's mainly handled by the system itself. And that is quite cool.
So there's clearly a lot of benefits to intelligent outage management. I suppose some distribution system operators might be wondering how. How does that kind of system, how do they deploy it on their network?
Yes, so how to deploy, that's quite interesting, because distribution operators have a slew of devices already in the field, and they're coming from a great history. And what our Siemens approach is to integrate as possible as much of this given history, because we're quite sure the investment can be not done from one day to the next day and changing all the equipment. That will not happen. It will be a wish from my side, but it will not happen. So we have to integrate existing substations, we have to integrate existing protection relays, SCADA systems and so on. And if there is nothing, like here at Scottish Power, then we install some new equipment, for example, to monitor the overhead line, or installing some fault passage indicators at the secondary substation and RTUs, get a clear picture of the grid itself, and later on to act on this information.
So clearly data is involved in moving from monitoring to automation to applications. What's the kind of time frame like between, applying the technology, allowing the data to gather and learn, to that point where you can be automating?
Our automation system is quite intelligent, so we don't need a lot of data. That is quite interesting. So we are coming, let me say, more or less on a rule-based stuff. But what is quite interesting, what you told me about this data, and what the data also can be used later on. So beside of these kind of self-healing or whatever, because that it comes to the synergies. And all these kind of devices, fault passage indicator in the cloud, he can measure current, for example. So he can give me a load profile on this specific line, which I never had a load profile before. I have some indication, okay, how often was the switch turned on and off? So I can do some predictive maintenance, or even I can use it for grid planning. Okay, are the grid loads in the same shape as before, or has it changed a little bit, for example? Because all our customers are changing, like we also. Our behaviors are different, our works are different, and so on. So this kind of stuff can be used, and that is, from my perspective, one of the greatest benefits. So we need some basic automation in the field to gather all this information, also to act on the grid, but later on these data are usable for every other applications, like grid planning, like intelligent asset management, or some other topics which we can put to some intelligent cloud service, which do some analysis we never saw before. But first of all, we need some basic data, and these kind of basic data we can provide. That's quite cool.
Okay, and a final question, Oliver. What's the adoption like at the moment of medium, low voltage grid monitoring in Europe?
In Europe. So from my perspective, have a quite fair automation on the high voltage. We go now to medium voltage and to low voltage. And from my perspective, we go now in a parallel way. So it's not only medium voltage or low voltage. So I think we have to combine, because otherwise we have some blind spots between. And that is also not fair to say, okay, yes, now I have some meter infrastructure, I have now the very good low voltage infrastructure, but maybe the medium voltage line is broken. That will not help me at all. So I need a certain rollout scenario for both levels. And as I mentioned before, because of this 2080 rule, it's quite fair to start with some dedicated areas to do this kind of piloting, to get first experience, because also we have also to think about the operational stuff which is outside. So it must be also quite easy and understandable to, let me say, to do this rollout, to do the maintenance, and even if the systems are able to do something like remote control or do some automation, also this kind of stuff must be very, very clear to them. And I think that is, let me say, that is the most important part for this kind of adaptation of this kind of rollout scenario, to bring it to a success to the field level, not only to a pilot.
On that note, we're going to finish. Thank you for your comments, Oliver.
Yeah.
Thank you for joining us in the Engerati studio. You can watch plenty more Engerati videos on our YouTube channel. Goodbye.